Ever wondered what happens when your computer gets so small, it starts breaking the laws of physics? Well, buckle up, bubble butt, because we're about to dive into a world where electrons play hopscotch on a molecular playground.
How small can we actually make computers before they stop working?
And what if the very thing that's been holding us back could be the key to unlocking a whole new level of computing power? Listen up, you little quantum quilt. We're about to stitch together a story that'll make your circuits sizzle and your motherboard melt with excitement. Quantum transistors shrink beyond 1 nanometer. First, you got to understand that we've been shrinking transistors, the tiny switches that make up every computer chip, for decades. We've gotten so good at it that we can now cram billions of these bad boys onto a chip the size of your fingernail. But get this, we're hitting a wall, a quantum wall to be precise. So, when transistors get super tiny, like below 10 nanometers, weird stuff starts happening. Electrons, those cheeky little particles, start acting like waves and doing whatever the hell they want. They're tunneling through barriers, leaking all over the place, and basically throwing a quantum rave in your circuits.
Hold up, are you telling me electrons are partying in my phone? No wonder my battery dies so fast.
But here's where it gets interesting. Instead of fighting this quantum madness, some clever researchers decided to embrace it. They've created a new kind of transistor that's so small, it's basically just 2 pieces of graphene with a single molecule sandwiched between them. Now, this isn't your grandma's transistor. It uses something called quantum interference to switch on and off. Basically, when the electrons are vibing together, current flows. When they're not, it doesn't. It's like a nightclub where the bouncer decides who gets in based on how well they dance together.
So you're saying my future computer might work because electrons are doing the electric slide?
That's lit! The cool thing is, this new transistor is ridiculously small. We're talking 1 to 2 nanometers. That's about the size of a single molecule, folks. And get this, it actually works better at this tiny scale than our current transistors do. But wait, there's a catch.
Isn't there always?
Right now, these quantum transistors only work when they're cooler than a polar bear's toenails. We're talking about 30 Kelvin, which is like minus 240 degrees Celsius. Not exactly something you can stick in your pocket without giving yourself frostbite.
Great, so my future phone will need its own freezer? Talk about a cool new feature.
And that's not all. We still haven't figured out how to connect these transistors together to make actual circuits. It's like having the world's most awesome Lego brick, but no idea how to snap it onto anything else. But here's the thing, if we can figure this out, it could be a game changer. We're talking about potentially scaling beyond 1 nanometer technology in actual physical dimensions, not just in marketing speak. This could mean computers that are exponentially more powerful and energy efficient than anything we have today.
So you're saying my future gaming rig might be smaller than a grain of sand, but more powerful than a supercomputer? Sign me up.
And by sign me up, I mean wait patiently for years while scientists and engineers figure out how to make this actually work in the real world. Let's be real, we're still a long way from having quantum transistors in our pockets. But the fact that we can now build transistors using quantum effects instead of fighting against them, that's huge. It's like turning your worst enemy into your best friend and then discovering they've got superpowers. Here's the harsh truth. Our current approach to making computers faster and smaller is reaching its limits. But the surprisingly inspiring part? The solution might lie in the very quantum weirdness that's been giving us headaches. So, next time someone tells you quantum physics is just theoretical mumbo-jumbo, you can hit them with this mic drop. Actually, quantum interference might be the reason your future smartphone can simulate the entire universe while fitting in your pocket. And by simulate the entire universe, I mean run Crisis without breaking a sweat.
Wait, are you saying the universe might just be one giant quantum computer? Mind